welcome dito sa ating YouTube channel. Ito na yung lesson 27 sa ating complex analysis. Ito na yung sequence and series. Okay, so mag-start muna ako sa sequence o yung convergence of a sequence, then sunod is convergence of a series kasi yung focus talaga ng chapter na to is all about series. Okay, so let's talk about the convergence of sequence dito sa real number o dito sa complex number. Okay, so an infinite sequence C sub 1, C sub 2, C sub 3, C sub n, then of complex number has a limit of z if for each positive number e there exists a positive integer n naught such that c sub n or the absolute distance c sub n minus z is less than epsilon whenever n is greater than n naught. So again, absolute value pa rin yan. Pinag-uusapan pa rin dito is yung buntot o yung tip nung z. So in drawing, para siya mangyari or in notation, yung limit, sabi in notation, yung limit ng c sub n as n approaches infinity is equal to z. Okay, so in drawing, na mag-iitsura niya. So since lahat ng complex number is nakaka-form ng tawag dito ng mga this, so nabanggit ko yun last time. Okay, so let's say ito yung z, so let's say ito yung c sub n, okay, then c sub 1, c sub 2, c sub 3, c sub 4, c sub 5. Okay, so ang ini-imply lang niya, kung ito yung limit na z, okay, yung c sub n, habang palapit ka ng palapit dyan, so diba yung z na yun is nakaka-form yan ng this, lahat ng complex numbers nakaka-form ng this. So ito yung open this na na-form lahat. Okay, so ayun nga ibig sabihin niya, habang yung absolute distance nila, wherein ito yung epsilon distance. Okay, so ayun yung epsilon distance niya. So ibig sabihin lang niya na, so the more na tumataas yung n, so the more na lumalapit siya dun sa z na yun, which is a complex number. Tapos ang mayroon dun, yung absolute distance, yung complex number, yung z na yun is just an epsilon radius. So may epsilon radius lang siya, and then at the same time, almost nasa loob niya or almost neighborhood niya na si c sub n. Okay, yun yung ibig sabihin niya dito. So kung tatanungin mo kung ano yung neighborhood, yan ay pinag-usapan nyo sa real analysis, nabanggit na sa inyo ang ibig sabihin ng neighborhood. So iba nga lang yung dating dito na neighborhood. So pagkakalala ko yung neighborhood is something na as long as makaka-form ka ng open interval within sa loob niya. Kaya kunyari, neighborhood yung x and y, as long as merong open interval na contain si x and y. Tama, parang ganun yung pagiging neighborhood. So hindi ko na rin sure kasi hindi ko na rin maalala sa dami na rin na iniisip ko. Again, hindi yun yung eksakto Hindi ko kini-claim na yun ay tama. Kasi inaalala ko lang din. Okay, then we have theorem. Suppose that c sub n is equal to x sub n plus iy sub n and z is equal to x plus iy. So again, c sub n is the sequence ng ating complex number. Ngayon, since sequence siya ng complex number, napansin mo, sequence din siya in standard form. Meaning, sequence ng real part, then sequence ng imaginary part. And yung z is equal to x plus iy, so ito nga yung usual standard form natin. Then, the limit of c sub n is equal to z as n approaches infinity. If and only if the limit of x sub n is equal to x as n approaches infinity and the limit of y sub n as n approaches infinity is equal to y. Okay, so, ayun nga no. Kung yung limit ng c sub n is z, tapos yung z is x plus iy, yung limit ng x sub n is x. Yung limit ng imaginary part naman niya, which is yn, is y. Okay, ganun dapat yung mangyayari dito. So, parang ang nangyari, dalawa ito test mo, usually. So, para mas ma-verify mo na tama. Pero, ang gagawin sir, ipuprove ko tong theorem na to, pero ipuprove ko yung converse part. Kasi baka isama ko sa problem set yung implication part lang niya. Okay, so, paano ba to? So, ipuprove ni sir yung converse part. So, ito yung proof. Ito yung proof ng converse part. So, iba assumption. I-assume natin na yung limit ng x sub n is equal to x, yung limit ng y sub n is equal to y. Okay, so since limit of x sub n is equal to x and limit ng y sub n is equal to y, so assuming na n approaches infinity na yan, okay, then okay, for every epsilon greater than 0 there exists n sub 1 and n sub 2 such that gagawa ko ng dalawa tulad doon by definition yung x sub n, yung absolute distance ng x sub n minus x is less than epsilon over 2. So, i-halfway ko na agad whenever n is greater than n sub 1. Next, yung absolute distance ng y sub n, so y is less than also sa epsilon over 2 whenever meron akong n na greater than n sub 2. Okay, so again, assumption pa lang yan. Then, we take or choose n naught to be the maximum, since limit ng pinag-uusapan, limit ng sequence, maximum between n1 and n2. Okay, so since meron tayong delta or yung n naught natin, okay, so we can find yung limit ng c sub n minus z. Okay, kasi ito naman talaga yung hinahanap. Ipoprove natin na yung limit ng c sub n is equal to c. So, kailangan ito ay less than epsilon. So, this is equal to x sub n plus y sub n minus x plus iy. Okay, then rearrange lang natin yan. Kunin natin yung dapat nakuha x minus x sub n plus ito. So, this is less than or equal, ito triangle inequality ko na, x sub n minus that is x, kasi makukuha ko yung part na yun. Okay, then yung negative, di ba magkakaroon ng negative, so plus to, tapos negative yun, ilalabas ko yung negative somewhere na yun, tapos sa triangle inequality, di ba mangyari magiging, di ba, y sub n minus y, tapos lalabas ko lang yung something na, tama lang pala, negative na, okay na pala, ilalabas ko lang, sorry, yung I plus I, then y sub n minus y. Okay, so ayan yung inilabas ni sir afterwards. So ngayon, ano sunod natin gagawin? Ang sunod natin gagawin dyan is that eto, di ba yung y na yan, ay yung I na yan, ngayon, aware tayo na less than or equal siya pag tinanggal natin yung imaginary part. Kung naalala mo, kunin mo yung modulus. Nari, yung z is less than sa modulus of z. Okay, so yung z mismo is less than sa modulus of z. Okay, so ang gagawin ko, this is also less than sa x sub n minus x plus y sub n minus y. Okay, so mas malaki pa rin to kumpara doon. Kumbaga, pure real part na yung kinuha ko. Hindi talaga real part, I mean. So, parang tinanggal ko na or disregard ko na yung pagiging complex number niya. Okay, again, since nga hinahabol ko yung c sub n. Next, by definition or by our assumption, this is less than epsilon over 2 plus epsilon over 2, which is equal sa epsilon. So, yung c sub n minus z is less than epsilon. Therefore, yung limit ng c sub n as n approaches infinity is equal to z, and that is done. So again, yung converse part lang muna yung pinrove ko para mapakita ko sa inyo. So meaning yung implication part o yung papunta, that is, assume ko to, dapat ito yung lumabas na dalawa. Okay, so sir, pwede bang baliktarin namin yung mangyayari? I think possible naman, pero syempre mahirap biyakin yan pagdating dito. Kailangan mapalabas mo yung dalawang yan. Okay, now let's apply this. Ngayon, ano lang pala, sorry, by the way, ano lang ba ibig sabihin nito? Ang gusto lang i-imply ng theorem na to is, ang gusto na ipakita sa atin is, kung yung limit ng c sub n, okay, is equal to c, pwede natin siyang gawin ganito. Okay, yung limit ng x sub n plus y sub n is equal to x plus iy. Or, pinaka-simplest form, limit ng x sub n plus I limit ng y sub n. Okay, and that is also equal pa rin sa x plus iy. Ayun yung ibig sabihin na. So, ibig sabihin pwede natin siyang hatiin. Ibig sabihin lang, ang gusto nang pakita, what if kunin mo na yung limit ng real part, kunin mo yung limit ng imaginary part. Kung nahihirapan ka kunin mismo yung as a whole, kunin mo na lang yung by parts na. Kunin mo yung limit ng real part, kunin mo yung limit ng imaginary part, then gamitin mo yung form na yan. Limit ng x sub n plus I limit ng y sub n, that is equal sa real part o yung limit ng x sub n plus I limit ng y sub n. Then, yun yung magiging limit natin. Okay, so yun yung ibig sabihin niya. Next is, we have an example or examples para dito. Okay, so number 1, the sequence c sub n is equal to 1 1 over n cube plus I. For n is equal to 1, 2, 3, dot, dot, dot. So, converges to I. So, yung sequence na to, converges to I. So, meaning, yung limit niya is dapat, ang sagot is I. So, check natin siya by definition muna, or meaning kunin natin limit. So, ang gagawin ko, kunin ko yung limit ng c sub n as n approaches infinity. Okay? And that is equal sa limit as n approaches infinity ng 1 over n cube plus I. Okay? Then apply natin to. Yung ginawa niya, hatiin natin siya para hindi mahirapan. This is limit as n approaches infinity ng 1 over n cube plus I limit as n approaches infinity ng 1. Kasi may imaginary 1 yun. Okay, next, as n approaches infinity, this is 0 plus I times 1. So, therefore, this is I. Okay? So, ito yung limit ng c sub n. Okay, so, kung dyan ay gusto mo siya i-prove, gamitin mo na yung usual way para kumuha ng limit ng sequence. So, paano ba kumuha ng limit ng sequence? Okay, so paano ba yung prove nun? Okay, prove natin. Prove that limit ng 1 over n cube plus I is equal to I. So, let epsilon be greater than 0. So, there exists n or n naught, okay, greater than 0 such that yung limit o yung 1 over n cube plus I minus I is less than epsilon whenever n is greater than n naught. So, ang goal natin is makahanap tayo ng n, or I think makahanap tayo ng n naught. Okay, so mangyari, consider natin to. So, this is 1 over n cube plus I minus I is less than epsilon. So, this implies that 1 over n cube, okay, ngayon, ibig sabihin ng 1 over n cube na yan, since siya ay less than epsilon, pwede natin i-take na lang yung i-disregard absolute value. This is equal sa 1 over n cube, which is less than epsilon. Since naghahanap tayo ng n, okay, so ang gagawin natin, this is, kunin ko to, this implies that 1 over epsilon is less than n cube. Then kunin ko yung cube root. So, this implies that 1 over cube root of epsilon is less than n. So, we choose. So, choose n to be 1 over cube root of epsilon. Okay, so since nakahanap na ako ng n na ganyan, tapos, ang goal lang naman kasi ng pag-prove ng sequence is makahanap, as long as makahanap ka ng n na magsasatisfy dun sa ating equation or sa ating definition, then therefore yung limit exists. Okay, so since nakahanap na ako nyan, therefore the limit, okay, so hindi na ako mag-checking, so the limit ng 1 over n cube plus I is equal to I as n approaches infinity, and that is done. So again, kung gusto mong gamitin yung definition yung theorem natin ay yung usual way ng pag-prove ng mga sequence. Okay? So for number 2, find the limit of c sub n is equal to negative 2 plus I times negative 1 raised to n over n squared. So dito di ko na ipoprove, papakita ko na rin yung solution part niya. So I think para siyang converges kasi dito iba eh. Okay, so check natin. Yung limit ng c sub n as n approaches infinity ng c sub n is equal sa limit as n approaches infinity ng negative 2 plus I limit as n approaches infinity ng negative 1 raised to n over n squared. So obviously, dito pa lang sa part na to, dalawa sagot eh. Bakit? As n approaches infinity, as n approaches infinity, nangingibabaw na nag-a-absorb to na papunta ng 0. Tama? Pero, isa sa naiisip ko is that, alternating kasi itong part na to. Kunyari, anong nangyayari? So, kunyari, pag even, positive siya. Pag add, negative siya. Pero, isa sa sure natin naman na nangyari, di ba, kunyari, para ito yan eh. Ito yung 0. Okay, so ito yung parang negative 1, ito yung 1. So pag even or pag add, somewhere nandito siya. Okay, pag even, somewhere nandito siya. Pero kung papansinin mo, although alternating yung sign, pero sure ako na decreasing yung isang part, isang subsequence, kunyari may subsequence ako na pinorm, tapos yung subsequence naman is increasing, going to 0. Kasi nga, lower, mga less than ng 0 yung mga yun eh. Okay, so I think this is still 0 pa rin. So this is equal sa negative 2 plus I times 0. Therefore, the limit is negative 2. Okay, so naging confused lang talaga ako sa part na yun. Kala ko magda-diverge kasi nga hindi ko napansin na may n squared sa ilalim. So again in-imagine ko kasi ito, tinignan ko yung possible na mga cases na mangyayari dito. Okay, so ganyan pag kinukuha yung mga limit. Okay, so yun yung convergence subsequence. So hindi ko na masyadong inelaborate pa. So bakit ko siya diniscuss ng ganyan? Gusto ko na mangyari is ang term ng sequence, pag inad natin, magiging series. Yung bawat term ng sequence, pag inad natin, ang tawag doon, series. Yun yung isa sa mga precise definition ng series. Again, galing din siya, pinagbasihan din niya si sequence. Okay, so convergence of a series. Punta tayo doon. An infinite series, so that is summation of c sub n for n is equal to 1 up to infinity is equal to c sub 1 plus c sub 2 plus c sub 3 plus plus c sub n. Okay, so ang tawag dyan is summand. Nakalimutan ko yung term, summand. Okay, so summand yung mga tawag dyan. Of series of complex number converges to sum s if the sequence s sub n is equal to the summation of c sub n, which is equal dito pa rin. Okay, so ang ibig sabihin niya, converges daw sa sum if the sequence s sub n. So ano yung s sub n? S sub n is yung mga partial sum converges to s. We write, paano ba natin i-write yung partial sum na yan? Yung partial sum na yan is something na alimutan ko yung partial sum, paano ba nire-rate? Tama, yung limit ng s sub n, something na okay, so we write the limit of s sub n is equal to s kasi yun yung sum. Okay, so where s sub n is the summation. Dana. So again, nire-represent niya yung mga partial sum as the sequence. Okay, of that series. Okay, so nakaka-form kasi ng series. Ngayon, yung mga partial sum naman na yan, ano ibig sabihin ng mga partial sum? So for example, s sub 1, dito ko na nalagay. S sub 1, that is only c sub 1. S sub 2, that is c sub 1 plus c sub 2. S sub 3, that is c sub 1 plus c sub 2 plus c sub 3, then that something. Okay, ganyan yung mga partial sum na yan. Okay, then sabi dahil sequence siya, so since sequence siya, yung s sub 1 c sub 1, so c sub 1 siya, yung second term is c sub 1 plus c sub 2, s sub 3 is in term 3, yung third term is c sub 1 plus c sub 2 plus c sub 3. Okay, then another thing, medyo pasensya, medyo nag-iingay, dami yata tumama doon sa labas. Ewan ko sa ending na yan. Okay, so again ito yung mga partial sum. So imagine mo sa ano yung partial sum, ganyan siya nire-represent. Okay, so kung gusto mo siya represent as sequence yung mga partial sum, gawin mo na lang. Okay, then we have this theorem. So suppose that c sub n is equal to x sub n plus iy sub n for n is equal to 1, 2, 3 and s is equal to x plus iy, meaning capital X and capital Y. Okay, so parang ang naging dating, alam natin yung s yung sum. Okay, so yung sum ng buong series. So, anong nangyari? Hindi ko pwedeng tawagin na partial sum si x saka partial sum si y. So, ito yung sum of real parts. Ito yung sum of imaginary part. Okay, so katulad kanina sa limit, pwede natin kunin yung limit ng real part plus I limit ng imaginary part. Dito ganun din. Pwede natin kunin yung sum ng real part plus I sum ng imaginary part. So, yung nga sabi no, the summation of c sub n for n is equal to 1 up to infinity is equal to s, which is the sum. And if and only if yung limit o yung summation x sub n for n is equal to 1 up to infinity is equal to x or capital X, and the summation of y sub n for n is equal to 1 up to infinity is equal to y. So other thing, we can write this form. So yung summation for n is equal to 1 up to infinity ng x sub n plus y sub n is just equal sa summation for n is equal to 1 up to infinity ng x sub n plus I Okay, then plus for n is equal to 1 up to infinity ng y sub n. So, pwede natin gawin yung ganito. Okay, note na yung napag-aralan nyo dun sa inyong advanced calculus about mga test dito sa series is i-apply ko pa rin. Pero hindi ko tuturo na kasi nga magiging redundant yung dating ng subject eh. Okay, meron pa rin dito integral test, meron pa rin ditong root test, meron pa rin ratio test, andyan pa rin sila tawag dito, sila direct comparison test, okay, si divergent test or divergence criterion, parang ganun, I don't know. So, andyan pa rin yan. Usually, pag sinabi ko test the convergence, yun yung gagamitin nyo. So, I think aware na kayo dun. Meron din logarithmic test. Alam ko may ganun pa yan. So, hindi ko na siya ituturo kasi ang focus ko talaga dito is yung gagamitin ko yung series, i-represent ko yung function as a series or a power series. So, kaya nga nag-intro muna ako nito. Okay, kasi ito talaga yung goal ng chapter na to. Okay, so let's have the mark. Again yun yung pinaginawan. Hindi na ako maglalagay ng example. So, alam niyo na yung gagawin dyan. Okay, so if a series of a complex number converges, then the nth term converges to 0 as n tends to infinity. Okay, so imagine nyo na, if a series of complex number converges, so then the nth term converges to 0 as n tends to infinity. So yung bandang nth term, yung dulo, okay, converges to 0 as n approaches infinity. Next, the series is said to be absolute convergent if the series na summation ng modulus ng C sub n for n is equal to 1 up to infinity, again modulus dito in the absolute value is equal to the summation for n is equal to 1 up to infinity ng square root of x sub n squared plus y sub n squared converges. Kung ito nag-converge, meaning may sum to, so therefore absolute converges siya. So kung gusto mong kunin yung summation ng modulus ng C sub n, dito siya equivalent. Tama naman kasi ang modulus nito is square root ng x sub n squared plus y sub n squared. So na-imagine mo kung gaano karami yan. So maraming term talaga as if sa loob yan kung i-compute natin. So ganito naman yung absolute convergence dito. Okay, so number 3, the absolute convergence of a series of complex numbers implies the convergence of that series. So, yun nga, yun yung parang number 2 kanina. So, naka-notation lang siya. So, sabi the absolute convergence of series of complex number implies the convergence of that series. Kung absolute convergence ka, automatic, convergent ka. Okay, so, ano ibig sabihin? Kung nag-i-exist yung limit nung modulus nung series mo, okay, then therefore, ikaw ay convergent. So, kung hindi mo makuha hindi mo makuha by root test, by quotient term test, don't know yung mga ganun, kunyari integral test, hindi mo siya masolve. So what if ganito na lang gawin mo, kunin mo yung summation ng square root ng x sub n squared plus y sub n squared o yung summation ng modulus ng c sub n, yun na lang. So baka makuha mo, again, pag nangyari yun, therefore siya ay convergent. Okay, then number 4, let's have the remainder rho sub n, that is rho, hindi p. Okay, so the Greek letter rho, so rho sub n is equal to s minus s sub n. So ibig sabihin yan, that is the remainder. Okay, so paano si rho 1? So si rho 1 is equal to s minus s sub 1, which is equal sa s minus c sub 1. Si rho 2 is equal to s minus s sub 2 is equal to s minus c sub 1 minus c sub 2, and that so forth. So wala mo na yung gagawin ulit dyan. Okay, so ganoon na karami. So ibig sabihin, pag na-reach mo si p sub n, that is s minus s sub n, so almost likely this approaches to 0. Kasi nga, ang limit, sabi nga nila, ang limit ng s sub n natin, ang limit ng s sub n natin is equal to s. So almost 0 na yan, yung remainder. Meaning yung remainder dito is almost 0 na. Okay, dinefine lang as ganyan. Okay, so yan yung ibig sabihin ng ating remainder naman. So hindi rin ako magpapahanap ng remainder kasi ang importante talaga sa akin dito is yung mga Maclaurin test, yung mga Maclaurin series sa power, yung mga power series talaga, to be honest. Okay, next is the region of convergence. So sabi, this can be solved using ratio test. Kung naalala mo what is the ratio test is just the limit ng absolute value ng u sub n plus 1 all over u sub n. So I think dito is modulus pa rin siya kasi nga modulus yung pinag-uusapan. Okay, kasi nga modulus dito is parang ina-absolute value din, pero in a sense na dapat kinukuha natin yung square. So nagiging positive siya literal. Okay, so sabi nga nila, Pag kinuha natin yung modulus, ibig sabihin kinukuha natin yung radius. Okay, so kaya nga sabi, the region of convergence. So ito yung ginawa. So evaluate mo daw yung u sub n plus 1 over u sub n. Okay, so then, pag yung makukuha mo values nun, doon natin malalaman kung ano yung region of convergence. So check natin paano nakukuha ng region of convergence. Okay, so find the region of convergence of the series. So by the way, what is the region of convergence? Yung region of convergence pala is something na, kunyari ito yung complex number. So let's say dito siya. So kunyari dito center, hanggang dyan. So ito yung tinatawag na region of convergence na. So yung sequence na yan o yung series na yan, somewhere nasa loob na yan. Okay, so paano sir malalaman na may region of convergence or something na, actually una, radius of convergence obvious eh. So malalaman mo yung radius of convergence dito, kunyari may nakita kang z, kunyari lagi lang isa dito yung z. So isa sa mga sure ko is lagi lang isa yung z dito o yung z. Then pag may nakita ka somewhere sa kanya na kunyari mayroong minus z naught, okay, automatic ito yung radius. Okay, so kunyari nakita mo lang siya as z, okay, automatic 0 yung kanyang radius. Pero ang sense dito, ibig sabihin dito, pag 0 yung kanyang radius, ibig sabihin lang for all, kumbaga malawakan, kumbaga yung buong complex plane yung kanyang parang region of convergence. Pero hindi lagi may instances na yung region of convergence na is lahat, meaning yung buong complex plane. Ibig sabihin kasi dito, pag mayroong ka region of convergence, convergent ka sa lahat eh. Okay, ngayon ang nangyayari dito, kung yung region of convergence mo is 0, may dalawang klase yan. Kung 0, nakalimutan ko yung term. Pag 0 yung ating region of convergence, pag 0 yung lumabas na sagot mo, I mean, after nung kinuha yung ratio test, ang mangyayari is just, yung region natin, kumbaga, pag lumabas dito una, kunyari is 0, yung magiging region of convergence natin is modulus of z is less than infinity. So, ibig sabihin nga niya, lahat, kinuha ko. Ngayon, kung infinity naman lumabas ng sagot, ito yung most common kung infinity, ikaw ay convergent lang pag 0. Yun lang ibig sabihin. So, ibig sabihin, convergent ka lang sa point 0, hindi ka convergent sa lahat. So, ang dating nun, ang region of convergence mo is mismo yung point lang na yun, napakaliit lang, as if andun ka lang. So, parang tuldok ka lang. Yun ang ibig sabihin niya. Okay, then meron naman iba, lumalabas value is k. So, may instances yun. So, i-check muna natin kung convergence siya para malaman natin yung region of convergence. Okay, so find the region of convergence of the series. So letter A, the summation of c plus 2 raised to n over n plus 1 cube 4 raised to n for n is equal to 1 up to infinity. So ano yung mga dapat kunin? Una sir, kunin natin si u sub n. Okay, so ano si u sub n? Si u sub n yung nasa loob. So si u sub n is equal to z plus 2 raised to n all over n plus 1 raised to 3 4 raised to n. Next, si u sub n plus 1, ano siya? That is z plus 2 raised to n plus 1 all over, this is n plus 2 na cube, then 4 raised to n plus 1. Okay, kasi nga n plus 1, so n plus 1 plus 1, ganun mangyari. Yan, we are asked to find the region of convergence, so we need to evaluate the limit as n approaches infinity nung u sub n plus 1 over u sub n. Okay, so that is equal dito sa limit as n approaches infinity ng modulus ng unahin ko to sa ilalim. This is z plus 2 raised to n plus 1 all over n plus 2 raised to 3 4 raised to n plus 1 all over z plus 2 raised to n all over n plus 1 raised to 3 tapos 4 raised to n. Okay, so maghanap tayo ng pwede makancel. So ang obvious, makakancel natin isang z plus 2 tapos yung z plus 2 raised to n. So may matitirang z plus 2 na lang doon raised to 1 kasi cancel yan dito. So ito cancel kasi may makacancel tayo na isa doon which is yung n somewhere. So sa ilalim din makacancel si 4 raised sa n. So may titirang 4 doon, dito may makacancel tong 4 raised to n. So may makacancel dito, may matitirang 4 lang doon. Okay, then pagdating dito, I think wala namang matitira. As if yan lang. Ay, walang matitira. Yan pa rin yung matitira. Okay, so check natin. Ang nangyari is that this is the limit as n approaches infinity. So lalagyan ko ng malaking bracket. May natira na lang dito z plus 2. Isa na lang. All over. Meron akong n plus 2 raised to 3. Tapos 4 raised to 1 na lang. Then multiplied by, ito magre-reverse, magiging n plus 1 raised sa 3 na lang. Kasi nawala din yung isa. Okay, then let's say over 1. Okay, so check natin kung may cancel pa tayo dyan. So kung napapansin nyo, I think wala naman tayo cancel. Tama. So, sino yung mas mabilis lumaki in terms of values? In terms of value, mas mabilis lumaki dito is yung nasa ilalim. No? So, kunyari, as n approaches infinity, mas mabilis lumaki to rather than dun. So, obviously, dapat approaches 0 siya. Okay? Pero n plus 1 raised sa 3 tapos n plus 2 raised sa 3, iba pa rin yan eh. Iba pa rin yung sense niyan eh. Kumbaga, pag kinukuha mo yung limit yan, i-divide natin both side by n. Tama? Tapos, ang mangyari, okay. So, as n approaches infinity, ang mangyari, itong n plus 1, n plus 2 raised sa 3, n plus 1 raised sa 3, diba ang gagawin natin, di-divide natin siya by n cube. Kasi ganun mangyari. So, mangyari, may matitira na lang dito. Ang matitira lang dito is yung modulus ng z plus 2 all over 4 na lang. Again as n approaches infinity, ang mangyari kasi nan, di ba, expand mo to. N cube plus 3n squared plus 3n plus 9 or something plus 1. Then something ito. Then ang gagawin, di-divide lahat by n cube. So ang mangyari, 1 plus 3 over n squared plus 3 over n plus 1 over n cube. Tapos 0 lahat yun. Then 1 divided by 1, wala. 1 na lang. Then anong nangyari, z plus 2 over 4 na lang. Kaya ganun din natira. Okay na, as n approaches infinity. Kasi ganun naman talaga ginagawa usually sa kanya. Ngayon, ito yung test natin. Ngayon, if ito ay less than 1, ano ibig sabihin? This implies that z plus 2 is less than 4. Okay? So, ngayon, ang nangyari, may natira pa rin akong z. Ang nangyari, natira kong z is z plus 2 less than 4. So, ang nangyari, this implies that z minus negative 2 is less than 4. So, lumalabas na ito si z naught kasi ito yung r. Okay? So, meaning, ang region of convergence niya is ito. Okay? Kasi region of convergence, kumbaga dan siya convergent sa graph na yan. So, z plus 2 less than 2. So, yung center niya is negative 2. Okay, so yung center is negative 2, then yung radius niya is 4. Okay, so ganyan yung magiging mangyari. So in terms of drawing, paano ba mag-itsura sa drawing? Somewhere dito, drawing ko na lang. Are 1, 2. So assuming ito si negative 2. Okay, so gawa ko ng something na ganyan. So yung magiging region of convergence ng ating series na yan, so ito ay 4. Is dyan something lang. Yan lang. Yan lang mangyayari. Hanggang dyan lang siya convergent. Kaya nga sinabi, region of convergence. So, yung series na to, convergent lang sa part na yan. Ganyan lang. Hindi siya gagalaw dyan lang sa part na yan. Okay, so, ganyan ang gagawin pag minubas sa value. Again, pag minubas na z, tapos may nakuha ka. Ngayon, sir, i-assume ba natin na laging less than 1? Yes, mas mabuting assume natin laging less than 1 kasi ina-assume natin na yung region is mas maliit somewhere sa kanya. So, assume natin laging less than 1. Kung may lumabas na z. Kasi more likely, may hindi talaga lumalabas, nawawala si z minsan eh. Okay? So, kung ganyan, actually, mayroon siyang region of convergence. So, ito yun. Z plus 2, modulus of z plus 2 less than 4. Okay, next is letter B. Determine the region of convergence ng summation for n is equal to 1 up to infinity ng negative 1 raised to n minus 1 tas z raised to 2n minus 1 over 2n minus 1 factorial. So, I guess, re-recta ko na to para mas mapadali. Hindi ko nalalagay yung u sub n saka u sub n plus 1. Pwede nyo naman din gawin. So, this is limit as n approaches infinity ng n plus 1. Yun yung gagawin natin. So, this is negative 1. Tapos magiging n minus 1. N plus 1 minus 1. Tapos z raised sa 2. Tapos n plus 1 minus 1. All over 2 times n plus 1 minus 1 factorial. All over, copy natin yan, that is negative 1 raised to n minus 1. Okay, then this is z raised to 2n minus 1. Okay, all over 2n minus 1 factorial. Okay, so check natin ano yung matitira, or iayusin natin siya. This is equal sa limit as n approaches infinity ng, nahin ko to, lagay ko lang to. So this is negative 1 raised sa n plus 1, tapos may negative 1 raised to 1 on raised to negative 1, iniwalay ko lang. Then ito ay z raised sa 2n plus 2, so this is 2n plus 1 all over, this is 2n plus 1 plus 2, so this is 2n plus 1 factorial. Okay, ayan dyan. Then multiplied by, dito magbabaliktad, this is 2n minus 1 factorial all over negative 1 raised to, that n minus 1 pa rin to. This is n minus 1, tas ito positive 1 pa rin. Kasi gusto ko tanggalin agad yun is to n minus 1, then z raised to 2n minus 1. Okay, so check natin ano ba yung mga matitira. In this case, cancel to. Okay, then dito pwede ko sa evaluate to as ganito. Pwede kasi magiging ganito to, magiging ganito tayo. So this is 2n plus 1, 2n, then 2n minus 1 factorial. Okay, so cancel to. Okay, then dito naman sa isa, z raised to 2n plus 1, ang gagawin ko is, paano ko ba makakancel yan? Cancel lang yung z raised to 2n, z raised to 2n. So kumbaga meron lang dalawang z. Tama, makakancel yung z raised to 2n kasi ito equivalent dito. Ito ay z raised to 2n tapos z. Ito naman z raised to 2n tapos z raised to negative 1. So cancel to. So may z raised to negative 1 naangat. So magiging z squared. Okay, then negative 1 raised to 1, that is negative. Okay, since naka-modulus, mawawala lang din siya, madi-disregard. Okay, so therefore, ano natira? Ang natira lang natin is just, may number pa, ang natira is just the limit as n approaches infinity. Lagay ko muna yung negative 1 na yun, negative 1 z squared, kasi aangat yun. Then all over, may natira pang 2n plus 1, tapos 2n. Ngayon, as n approaches infinity, so nakamultiply yan. As n approaches infinity, so as n approaches infinity, this is equal to 0. Obvious naman kasi ito lang lumalaki. So hindi natin matatanggal basta-basta si z dyan. Talagang maapektuhan siya ng ating multiplier. Unlike sa kanina, nawala sila naging 1. Okay, so dito, nag-0 siya. So, since 0 siya, anong sabi ko kanina? Pag nag-0, ibig sabihin, yung region of convergence niya is, therefore, yung region of convergence na is negative, is less than negative infinity. Meaning, convergence ako sa buong complex plane. Yun yung ibig sabihin niya. Okay, lastly, for this video is, find the region of convergence of n factorial z raised to n for n is equal to 1 up to infinity, or summation n factorial z raised to n for n is equal to 1 up to infinity. Okay, so hoping na mag-equal naman siya sa 0 para magkaroon naman tayo ng convergent lang siya or convergence lang siya dun sa 0. So meaning wala siyang region of convergence. Ganun dating, wala siyang region of convergence. Convergent lang siya dun sa point, dun sa ating center or sa origin. Ganun na mangyari. Okay, so check natin. Kunin natin limit as n approaches infinity ng u sub n plus 1. So this is n plus 1 factorial z raised to n all over n factorial z raised to n. So ito may plus 1 pa, sorry. Okay, then syempre obviously n plus 1 makakancel natin yan. This is just equal sa limit as n approaches infinity. Ayusin ko lang muna. This is n plus 1 may matitira times n factorial, then z raised to n tapos z all over n factorial z raised to n. Okay, so obviously cancel yung mga yon. So minatira na lang limit as n approaches infinity ng n plus 1 times z, which is equal sa infinity as n approaches infinity. since ang nangyari nga equal siya sa infinity, therefore this is only converges which is equal sa 0. So the series is converges at z is equal to 0 only. So therefore wala siyang region of convergence. So kasi nga ayun na, point lang siya, doon lang siya. Okay, so di siya makaka-form ng region of convergence. Okay, so that's all for this video. So hoping nyo nakita mo yung mga idea. So again, ang focus ko lang is yung idea, definition, to some counting theorem. Kasi nga, ang focus ko talaga sa Taylor series, then si Lorentz series. Okay, so thank you for watching. So hoping na panoorin mo next lesson. Next lesson is all about Taylor series.